Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shakirin.
And I'm Mahani.
We are from MRSM KOTA PUTRA. We are advised by Ustaz Muhammad Bahaki
and Madam Nurul Aini.
So, we have aligned our invention through two sustainable development goals, which are SDG 7, that's focused on clean and affordable energy by the use of nuclear energy as the main source of electricity.
And the second one is SDG 12, which focus on the sustainable consumption and production by the saving usage of electricity in our daily life.
Regarding this situation, we have to take serious action in conjunction to support developing countries to strengthen their scientific and technological capacity to move toward more sustainable pattern of consumption.
Hence, we present to you a smart system that is integrated with nuclear energy. We call it as Smart i-NESS.
What are the main purposes of this innovation? First is to ensure sustainability consumption of electricity, to implement smart city in society,
and the last one is to monitor and control the electrical appliances according to the surrounding environment.
First thing first, we see the main source of energy is nuclear power supply, which supply 240 volts of electrical energy to the MCB, which is miniature circuit breaker that works to protect all the circuit from any abnormal conditions.
Next, the energy power in MCB will be transferred to relay, and it works as an automatic switch to control high current using low current signal, which is from 240 volt to 5 volt. Next, let's look out for the ESP32 microcontroller that acts as a main control system in our product, which is we use this kind of microcontroller because it can connect with Wi-Fi, so that we don't need to use any additional devices to access with the internet as we emphasize the IoT applications.
Let's move to the sensors that we have applied in our invention. First is DHT11 sensors. This sensors is used to detect surrounding temperature and also air humidity. In this project, we have applied the LCD I2C, that is an output to display the values of temperature and also surrounding air humidity that is recorded from the DHT11 sensor. Other than that, the value of temperature and also surrounding air humidity also can be monitored through the IoT ARDUINO remote app.
Move to the next one, which is IR sensor. We will apply this IR sensor in our system to detect any appearance of human, and this sensor will be connected to the output for automatic switch control of bulbs.
In this invention, we provide two ways to control the switches, which is first, through automatically detected by the sensors, and second, through the IoT Arduino remote apps in our smartphone that can be used and controlled easily by the user. These bulbs are the output of our light energy system that are connected to the IR sensor. As an example, whenever a people or human pass through the IR sensor, the bulbs will be light on. So, when the people are going away from the IR sensor, the bulb will be automatically light off.
The next one, which is fan, acts as an element to cool down the surrounding temperature, and it can be controlled through the app from Arduino IoT remote. The last one is a socket lamp, which is also be controlled by an Arduino IoT remote, and it is able to be used for electrical charging, and it will be automatically be cut off if the main switch in MCB is turned off.
Are the cost of construction materials of Smart i-NESS. MCB RM140, relay RM10, LCD I2C are RM20, ESP32 microcontroller RM32, DHT11 sensor RM10, and IR sensor for RM1.50.
Fan for RM15, socket outlet for RM3, and the last one is 2 bulbs for RM5.
Hence,
the grand total of this invention is worth RM236.50. As a conclusion, the Smart i-NESS is actually really helps us to save hundreds of ringgit, as even though the cost of manufacturing this is expensive, but we will have a long term of energy saving.
when we reduce the consumption of electricity, we can reduce the cost of building,
save more energy, money, and nature.
Thank you for your ears. Assalamualaikum.